we're going to start talking about Lewis dot structure. For this particular situation, there are not going to be a PowerPoint. It's just going to be me using the whiteboard. So almost like we were actually in class face to face. So this is still a little bit of basic chemistry that you're going to use later on, but this is some stuff that comes out of very nicely out of the material we've covered, and we'll start applying some of this material later on in the class, some of it earlier, some of it later. Right, so you want to be able to go back and forth with some of the other material. When you're done with this, you should be able to do homework 4. I'm going to break this up probably into 2 videos, and then there will be one more on molecular geometry. So let's talk about what Lewis dot structures do and don't do. Okay, a Lewis dot structure gives us a structural formula. It gives us the arrangement of the atoms, so what's attached to what, what's in the middle, what's on the outside. It will tell us about bonds, single bonds, double bonds, triple bonds. It will tell us about what are called unshared pairs of electrons, which you'll see soon. And it's also the first step to determining shape. It doesn't give us the shape, but it gets us the first step. Now, some things to consider. Lewis dot structure is for covalent compounds. So this is for compounds that are all made from nonmetals. Now remember, everything wants to have its valences, the octet rule, valence filled or empty, but in the case of nonmetals, everything wants its valence filled. That means everything is going to have 8 electrons. I do things in pairs of electrons, so 4 pairs of electrons, except hydrogen, which will have only 2 electrons in its valence. And if you remember what we talked about with the periodic table, that should be clear to you. And if not, you should definitely review that material. Now, over here to the right, I have the steps for doing Lewis dot, to the left, the steps for determining Lewis dot structures. And I'm going to go through each of these steps. I'm going to keep this up here as I go through several examples. All right. So the first step is to determine that, and these won't make sense until I do the examples, but we'll do it anyway. The first step is to determine the total number of valence electrons in the molecule, and then divide by 2 to get pairs of valence electrons. Then we're going to guess the central atom. And I know it sounds weird to say guess, but that's what we're going to do. We're going to guess the central atom. I'm going to move this stuff over and try to make things as big as I can. Now some help, it's never going to be hydrogen. The reason it won't be hydrogen is if you're in the middle, you have to be attached to at least 2 things. And for each thing you're attached to, that's going to be a pair of electrons. If you're attached to 2 things, that would be 4 electrons. Hydrogen can only have 2. It usually is the element that has the least number of valence electrons. Usually the least numerous, usually the least electronegative. Electronegativity is attraction for electrons, so the least attraction for electrons. Then what we'll do is we'll attach all the atoms to the central atom with single bonds, and after this stage, all the atoms should be in the structure. Then we'll determine the remaining pairs. I'm going to call it REM, and it's going to be the total pairs from step 1 minus the bonds you drew in step 3. Then we're going to put those remaining pairs, this is the tricky step, in the structure as unshared pairs on the outside atoms until the valences are filled. So they're never going to have more than 4 lines touching something. And then if there's any left, we do the central. After this stage, all the atoms and electrons should be in the structure. Then we check the valences. Everything should have 4 lines touching it except hydrogen, which will have only 1. That means it shouldn't have 5 lines either. And then if there's a deficiency, something's not filled, we're going to convert an unshared pair on an outside atom into a bond to the deficient. All right, I hope you're sufficiently confused. Now I'm going to go through some examples. Let me just clear this off. All right, so the first example I'm going to do is I'm going to do methane. All right, so we're going to draw the structure for CH4. All right, so looking over here, step 1, determine the total number of valence electrons. So you might want to pull out a periodic table for this. This should be a reminder. We just did this. You were just tested on this. Carbon has 4 electrons in its valence. If you look, it's in group 14. Hydrogen has 1 electron in its valence. From the formula, there's 1 carbon. There's 4 hydrogens. That means there's 4 electrons and 4 electrons, which is 8 electrons. Divide that by 2, and we get 4 pairs. That says pairs. All right, so we're going to have 4 pairs of electrons. Now we're going to guess the central atom, and in this case, the central atom is going to be carbon. Then we're going to attach everything to the carbon. So how should you attach it? First guess is symmetrical. Why? Nature is symmetrical. So we're going to draw that. All right, we've attached everything to the central atom with single bonds. This is steps 2 and 3. So now, step 5, we're going to determine the remaining pairs of electrons. Well, we had 4. We've used 1, 2, 3, 4 bonds. That means there are 0 remaining pairs. So that means we don't have to worry about step 5. So now we're going to go to step 6. So we're going to check everything. And you see the hydrogen has, this one has 1 line touching it, 1 line touching it, 1 line touching it, 1 line touching it, and the carbon has 4 lines touching it. 1, 2, 3, 4. So just to redraw it over here, so you can see it, that is the Lewis dot structure of methane. So this one just fell out for us. Now again, you can see carbon's in the middle, hydrogens are on the outside, all single bonds. So that's my point, is that we didn't really have that information before, we just knew this. All right, so I'm going to clear this. If you want to keep it and get a little bit better look at it, hit pause on the video. I'm going to count to 5, then I'll clear it. 1, 2, 3, 4, 5. All right. Okay, so now I'm going to do another one. We're going to do ammonia. I'm going to leave these structures, this thing up here. Okay, so again, if you want to hit pause and try on your own to count the valence electrons, go right ahead. Okay, nitrogen has 5 electrons in the valence. Hydrogen has 1 electron in the valence. There's 1 nitrogen. There's 3 hydrogens. That means there's 5. That means there's 3. That means there's 8 over 2. Again, we'll do some that don't just have 4. All right. So now what we're going to do is we're going to write nitrogen, and we're going to put the hydrogens around it. 1, 2, 3. All right. Now, that's steps 1, 2, and 3. Now we're going to count our remaining pairs. Well, we had 4. We've used 1, 2, 3. That means we have 1 pair of electrons that we have to put in that structure. Now I recommend that when you draw these, at each step that you're going to do something, redraw it. So now the question is, where do I put that 1 pair? Step 5 says we put it on the outside atoms until they're filled. Well, in this case, the outside atoms are filled. Hydrogen will never have more than 1 line touching it. So then we go to the central. All right, so we're going to put an unshared pair of electrons right there on the nitrogen. Okay, now we have all 4 lines in the structure. Everything's in the structure. So now we're going to count. Hydrogen has 1 line touching it, 1 line touching it, 1 line touching it. The nitrogen has 1, 2, 3, 4. So that would be the Lewis dot structure of ammonia. Right? Okay, I'm going to try to squeeze another one in here just so we can maybe get more than one on the same thing for you. Let's try water. All right. Okay, so water has, you know what, I'm going to just clear it. Sorry. All right, so now let's do water. I'm just going to do examples. Again, you can try this on your own. There's a hydrogen and there's oxygen. Hydrogen has 1 electron. You see, I'm being very methodical, step by step. He who skips steps falls on his face. Oops, look what I just did. Talking and drawing at the same time. All right, let's try that one more time. I'm not going to redo the video because I screwed up. Okay, there's 1 electron. There's 6 electrons. There's 2 hydrogens. There's 1 oxygen. Right? That means that there's 2 electrons. That means that there's 6 electrons. That means that 8 electrons over 2 is, again, 4 pairs. All right? So again, in this case, we're going to do some that don't have hydrogen. Like that. Right? Make sure you don't draw it inside out and put 2 oxygens instead of 2 hydrogens. I've seen some very creative structures in my career. All right, so now the next step is we're going to determine the remaining pairs. And you can do the math, pretty simple. There's 4 pairs. I've used 2, that means I have 2 pairs. Where are those 2 pairs going to go? They're going to go on the oxygen because the hydrogen is filled. All right, and let's count. 1, 1, 1, 2, 3, 4. There you go. That is the Lewis dot structure of water. All right, I'm going to stop this video here, and then I'm going to do another one that's going to pick up, and I'm going to do 1, 2, 3 more examples. Maybe I'll do a 4th just for kicks. Okay,